So we've kind of talked about a lot of the background information here, but we haven't really gotten into why these particular complexes, exhibit the properties that they do. So the two main properties we're going to look at for the rest of the chapter here are the color and the magnetism. I've mentioned these before, and we've talked about how electrons can be excited from one orbital to another, but we really haven't talked about why or what's the impact or how we can change the color or manipulate the color. In order to do that, we need to look at bonding theories of transition metal complexes. And the first theory that was introduced was something called valence bond theory. And this theory was more of an explanation than kind of a theory. And we basically stated that the metal acts as a Lewis acid, the ligand acts as a Lewis base, there's an attraction there, and complexes form. It doesn't really go into the nitty-gritty details of why particular things happen. But we're having this sharing or of electrons forming these bonds. A more extensive theory is something called molecular orbital theory. And this basically extends on the theory that was shown in chapter 9 of your textbook, where you have these bonding molecular orbitals and anti-bonding molecular orbitals. The bonding molecular orbitals go down in energy, the anti-bonding molecular orbitals go up in energy. This theory uses advanced mathematical group theory. It's a lot of geometry type proofs. And if you're really interested in this, I would highly suggest you take Chemistry 651, because we talk about group theory probably in the first 4 weeks of that particular course. If you really want to truly understand all the details of the color, you need to go into this theory. The problem is, if I tried to teach this class that, people's brains would probably explode, right? It's crazy math. It's like Good Will Hunting stuff, where he's drawing out his little iterations, right? So the question is, how can we take the relevant information from this molecular orbital theory and kind of make it relevant to a general chemistry class where we can teach all these concepts and kind of simplify the approach? So the theory that was developed for this is something called crystal field theory.